Alright, students, so if you're coming into the room, if you could please get out your math journal.
Notebook or
What?
book?
Yeah, like your notebook.
Okay.
And what I want you to think about real quickly is how you find the area of this room. Yeah, it's classroom. Well, whatever you're thinking, just put it down. We're going to talk to your partner when everyone's in here. So right now we're just waiting for everyone to come in here. So I just wanted you to think about how you find the area of this room. So think about it in your head, and then we're going to talk to our partners for a second about it.
This classroom?
Yep, this classroom. How you would find the area. Okay, so it looks like we have pretty much mostly everybody here. So if you would, turn and talk to your partner for a second about how you think you might find the area of this room. So Claire, you can talk to Johnson.
You take but if they're asking like how to do it, Lane has the way. But if they're asking like what they're doing, then I would say yeah. And then you would do the way, so you wouldn't have to do probably and if it would be really easy if
How do you think you'll find the area?
the classroom is a square and you measure one side, it's going to be the same as the other. Yeah.
No, they don't have any information. They just want to know the
Bookshelf gets me confused.
The bookshelf looks like it's curved.
No, because you can see the wall. You can see up there the right angle that turns. And there's another right.
Alright, class, LIS?
Yeah.
Okay, perfect. So, does anyone want to share what they think they would do to find the area of this room? Go ahead, Jory.
I would like measure length times width, but I'd use like yardsticks instead of a little ruler because if you get a little ruler, it takes so long.
It would. That's a very good observation. So we want to use something bigger than a ruler, like a yardstick. And you said length times width. What do you think, Evelyn?
I agree with something like that, but instead, because there's like that one, I split the room into two rectangles, and then multiply one rectangle and then the other rectangle, and then I add those areas to get full area. But you can't
Okay,
split a
break it-
building in half. No,
Break it down a little.
like imaginary split.
Yeah, like an imaginary split. Yeah, okay, that's a good strategy. Yeah, I like both of those strategies. Alright, so today we're going to use what we know about area to demonstrate what we know about division. So we're going to demonstrate knowledge of division strategies by creating a ratio, table, or array to divide a 3-digit number by a 1-digit number. So first, we're going to take a look at this problem right here. So two fourth graders started solving the same problem in two different ways. Can you figure out what problem they are solving? Identify and complete the models they use to solve the problem. So to start with, so this is the first problem. The second one is covered stuff. So I want you to take a second and look at this table. I don't want you to actually solve the table yet. But we want to see if we can figure out what is the actual problem that we're solving. Two hands are ready. Anyone else have any? Okay, go ahead, Faye, what do you think? Well, so you think it's going by time? Why don't you guys try to talk to your partner for a second? Get on any observations that you've noticed about things and see if you can figure out what the actual problem that we are solving is. Okay, so good. It is starting out that way, isn't Alright, class LIS? Alright, so we're going to share a few more observations here. So, Evelyn, what are you thinking?
I'm thinking the problem that we're solving is 450 divided by 3.
450 divided by 3.
Because on the end it has 450 and it has on top 1 equals 3. So it has to be 450 divided by 3.
450 divided by 3. You guys agree with that one? Yeah? Yeah, because they're trying to figure out how to get to 450. So I heard another way of saying the same problem. Jonathan, what did you say?
I'm thinking like 3 times something is 450 because 1 equals 3 and they're trying to get to 450.
Yeah, so you see how you can use.
Like 450 times 400, I meant 45 times 10 equals 450. So if we can figure out how many that could be, we might be able to figure it out. I don't think that would.
Okay, hold on, stop for a moment. So we have 2 ways of looking at this problem. So 3 times what equals 450, which is the same as 450 divided by 3. Right? Okay, so now we're going to take a look at our second problem. Okay, so this, what are we doing in this problem? Okay. Turn to your partner, notice any observations that you have.
Did you know the area of that one? See what it equals to get. Trying to find that. Yeah. Trying to find the area. Alright. You try to find the area of the next one. It's like 300 plus what? Find out the area. I know that you next to that area.
Why are you pulling on a pen?
Wait, no, you're
Alright, who has LIS? Alright, so who wants to share what they are thinking about this problem? Yes.
I think we're trying to find the area.
On the area, okay. And what are they trying to get to, you think? 450, very good. Because it's this one right here, right? But what kind of a model is this?
It's the area model for division.
The area model there. We can use that for multiplication and division. So these arrows are indicating, what are they telling us that we're doing with these? Yes, 2 glasses equal 450. So, if we were going to solve this problem in number 2, what number would we be looking for? Which part of this? Claire?
The box doesn't have anything.
The box doesn't have anything in it. Okay, very good. So we know that these 2 numbers, what is this showing us? This part. Is that it?
That part is showing us 100 times 3 is 300, but then it doesn't show what the other one is, so we have to figure out what that one is. And for me personally, looking at that one, first glance, it looks easier than student one is doing. Kind of like, I feel like a ratio table is like, I mean, ratio tables like easier, but like it takes a little longer than doing the 2-part area model.
The area model? Okay, I like that. So, if we know that this is 300, we need to get to 450. What do you think we should do next to finish this table out? Yes.
That we could add up. I was supposed to buy something. We could add 100.
Okay, so you could do that, but what we want to do is finish it out the way that they started it. We don't really want to break it down to a third piece. We want to figure out what they would do to complete this piece, right? So, Claire?
Well, if I know that 300 minus 45 would equal 150, so I know the answer would be 150. I know that we can take away the 0 and just like stick to the side. 3 times 5 would equal 50. 3 times 5 would equal 15. Put a 0 at the end of 5. So 50 would be 50 would be up on the top.
Okay, so 50 would be our missing dimension. Okay. Beautiful, good thinking there. I like that. So we see how she did that. So she knew that this area was going to equal 150 because 450 minus 300 equals 150. She started there. Then what she did was she knew 3 times something has to equal that 150. Or another way to look at it, 150 divided by 3 would equal the 150. Okay, so now turn and talk to your partner. I want you guys to try and work on this one, this ratio table. So with your partner, try and finish that table for them. So I'll start by doing what they have right here. The 1 and the 3, the 5 and the 15 and the 10 and the 30. And then try and finish it out. So where would you jump to next? Remember, we want to get to the 450. Okay. Oh, nice one.
Thank you.
Thank you, sir.
What is
Okay, thank you.
so one is
Yeah, that's very stiff. Do you wanna, I'm gonna tell you something. Okay.
stop. Don't stab me, sir. That's
Yeah, the one So, you have, okay, so you have 15. So, let's look at your 15. So, this in your 10. Let's see here. 5. What do you do with this 2? Yeah. It was like that. Okay, so what kind of jump do you make next? What? All of that. Okay.
How did you see? You already got 600.
My main for Jordan.
So then I'm getting. Yes, this is so confusing.
It's not.
The one that you do 4 times 100. No, I know the answer.
Yeah.
The answer is hard, but I'm not. Why they're not pausing?
Think about so
Yeah, I'm not done. What's 150 times 3? Let's do 150 times 3. What's 100? What? You're gone. Definitely not 460. That's 300. That's 360. I'm at 300. I got it. You're at 360. I got it. 360 times 3. He already got to like 600. I'll do the 600. Smiley, what did you get for your You got no idea. Wait, what? Let's go. That's what I do. I kept counting by 200. I was 150 equals 120. I need to like get one higher. Imagine they made you go 1, 2, 3, 4, 5, 6, 7 in school. Imagine my head. You count. Look at my head. Imagine you couldn't jump by anything but 1. You have to go 3, 6, 9, 12, 15. Flipping out.
Alright, Elias?
Yes.
Alright, so I'm gonna have a few people share here. So we have a few different strategies I've seen. Oh, you have over here. Okay. Okay, if you wanted to share your thinking, you can. Here is the Ellen and
Okay.
you share your guys' too. You're gonna share first. Okay.
So first I jumped right to 10 and 30 because every time by 3s. So then I kept going by 10 until I got to 40 and I only noticed it was 120, so I knew I had way more. So then I started jumping by 20s until I got to 420, and then if I knew I jumped another 20 it would be not 450. Because when you jump 20s it's 60, because 20 is 60. So then I jumped 10 and got 450 times 30.
So you got by 10 instead. Okay, I like that. That's very good.
And I got 150.
Well, Tom, thank you. Right, and then you gonna take yourself one? So if you guys are confused about this ratio table, it'd be really beneficial to listen to what your classmates are doing up here.
I started what he did, and I just kept doubling. So then I did 10, which was 30, and then 20, which is 60, 40, which was 120, 80, which was 240, and then I did 160, which got me to 480, and I realized that was 30 more, and if I went back, 30 was 10, so I minus 10 to get 150.
Okay, so what kind of strategy did you use there?
The overnight strategy.
The over strategy. The strategies. Now, can you tell us why? Where are you getting these numbers from? Like, why does 20 equal 60?
Because I was doubling the answer.
Okay.
If it was like 10 was 30, so then I have to double
okay, I see. So because you're doubling the top, then you're also doubling your bottom. Does anyone else notice a particular pattern in these ratio tables? Claire?
That the people kind of
They do keep on knowing, but so what if I was confused about how to get my bottom number? So could I multiply one of these numbers by this number to get my bottom number? Anyone notice that? I don't know if you guys have discussed that about the ratio tables or not. So that was helping a couple people. One thing I pointed out that seemed to make it a little bit more sense was, so what we're really doing to get these numbers is, look, so you got 3 times 5 equals your 15. Then your 3 times the 10 gives you your 30. See that?
Yeah.
Then your 3 times your 20 gives you your 60. Does that make sense? Yeah. Okay. So then I will go ahead and sit down. Thank you for sharing yours. Claire, do you want to share yours?
I know that 5, since they already did 5 times 3 plus 50 and 10 times 3 equals 30, I noticed that if you add 5 and 10 equals 15, and 15 plus 30 equals 45, so I know that if I put a zero, if I put a 0 in the end of 15, it would equal 450.
450. Do you guys see how she did that? So she took a really big jump there. So she got it to a nice friendly number, and she could make a big jump. So she didn't have to fill out a really big ratio table to get there. You guys see that? I like that. That was really good. Thank you, Claire. Did anyone, do you want to share yours? No? Okay. So, can I share it? Can I share it? Okay, I just like your jump. Thank you. Okay. So, I'm gonna borrow somebody's real quick before I like one of their jumps here. So, you notice in this one, we have. So what I liked about this one, so they did the same thing that everyone else was doing, making these smaller jumps. But then when I got to 50, they knew that the 50 was 150. And then they did another jump to the 100, so they doubled that 50 to get their 300. And then they were able to stop there because they used their ratio table to figure out the rest, right? So we knew nobody would get to 450. So they took their 300, their 150, and added them together to get their 450. So then they knew they had to add these two together to get our answer. So the 100 plus 50 equals 150. All right, thank you guys for sharing that. Okay, so I want you guys to turn and talk to your partner for a second. We talked about 2 different ways of doing the same problem. They both got the right answer, same problem, but they did it 2 different ways. So turn and talk to your partner about which one of these models looks more related to area.
Because the second one actually has a box. The first one is a ratio table. The first one you can't really tell if it's area. The second one is an actual box.
Basically, this would end with
Okay, LIS?
Yeah.
Alright, so who wants to share which one of these problems do they think looks more like an area? But think
Second one.
the second one. Do you guys agree or disagree? Agree? Okay, I got a lot of agreeances. Now, my next question is, do you think that matters?
No.
No.
No? Then who agrees with Claire? So there's some agreeances, any disagreeances? No disagreeances, little uncertainties? You're right, it doesn't matter because you can use any strategy that you need to get the right answer, right? So even though this one looks more like an area, I mean it is an area model, right? That doesn't really matter. You can use this one just as efficiently as this one. It's a matter of what works better for you to get the right answer efficiently. Good, Haley.
And they're both the same, but just different ways.
Exactly, there's just different ways of getting there. Whatever is better for you, and the numbers too. Sometimes it's about the numbers as well, right? Okay, so we're going to solve some more problems like these on our own, but first we want to discuss a little bit of vocabulary here. So our units of measurement. So when we're talking about area, what do you think might be some measurements that we would use? So think about when I asked you how you would get the area of the room. What kind of measurements might we use for something like that? Marley?
Yards.
Yards. Yep, yards is a good one. And what else could we use? Evelyn?
Meters.
Meters. Okay. Yards. Meters.
Are meters and yards kind of like the exact same thing?
Not quite.
Isn't it like a range difference?
We'll talk about that in a second. What other things and forms of measurement can I use? Yes.
You could do inches, but it would be less efficient.
Inches. Inches. Okay, what else? Centimeters.
Yeah, meters.
Well, let's talk about that for a second. So, what might you measure? What might be an efficient thing that you're measuring that might be in inches? Jason? Well, we're gonna put feet down, so that's a different one, right? Let's say, cause I heard some people say that wouldn't be an efficient way to get an area. What might be an example of what it would be? Claire?
I was gonna offer hands and right here you can measure centimeters.
Yeah, so when you have when you're writing something smaller, because you can get an area of small things too, right? It doesn't have to be something that's really big. So let's see, I'm thinking of one more. You guys think of what it is? One more that we might use for measurement? Got it?
Millimeters.
Millimeters. You have another one? Evelyn?
Centimeters?
Oh, we have centimeters already. Russell? Kilometers. Yep, that's what I'm doing. Kilometers. Kilometers. Okay. Now, when we're doing area, how do we label that? Like, say we were using this room is a total of 50 yards. That's just a random number, right? Would I say it like that, or would I say something different?
This is 50 yards.
Jace?
50 square yards.
Square yards. Yep, that's important with the area is that it's square yards. You want to keep that in mind. So, yeah. So, for example, for feet, right? So we would have square feet. right? Not just feet, but square feet. See that SQ abbreviation? The same way. Huh?
20 million kilometers.
20 million kilometers.
Okay, so basically it's gonna be the same way for all of the rest of them, right? We're gonna do square inches.
Put 20 kilometers.
What was that?
I said put 20 million kilometers.
Okay. So turn to your partner for a second and think of some examples of different things that you would measure these with. So something that you would want to use yards for, something different you might want to use meters for, etc.
You talk with us too. So I'll talk to you. Oh, the sound. The magnifiers. True. No. Talk about my toaster. Nobody was talking about your toaster.
Okay, so can somebody tell me what's an example of something that they would do feet for? Feet. Feet? For your backyard, okay. What? Yeah, so can we think of something maybe a little bit, go ahead. What would that give us, an area? No. Evelyn?
For feet, you could use like this desk or like a bookshelf.
Okay, something smaller like that. So they're using feet. So think about how big a foot actually is, right?
You can measure your foot.
What about square meters? Anyone have an example for square meters? Peter? The whiteboard, okay. That's a good one. That's a very good one. Mira? The what? The viewboard? It might be a little too small. That might go back more to our feet, right? Alright, so what if we use miles?
Oh.
Square miles. Jory?
Maybe like it wouldn't be something in this classroom because like maybe you could do it on like a whiteboard, like a big whiteboard.
A big whiteboard?
All the whiteboards combined in the school.
All of them combined in the
all the
school?
whiteboards combined in the school.
So that's the way to think it's bigger.
Oh, it should be.
Nas?
They would have to measure with miles.
The area of a highway.
That's
Area of a highway, so let's elaborate on that thought a little further. Liam? Square miles. Big. The Blackbird Street, so what are we measuring then? So, you already got it?
Oh, I was gonna say, like, you could like a highway could go on like a long time. Like,
Yeah.
it could be a lot more than a mile.
There are
Yeah,
US highways like goes
That go like 5, 10.
no that goes throughout the entire United States.
We want to know the area of Menasha.
You could use miles for that.
That, yeah, we can
Yeah,
call it
miles. You could use that for a farm too.
that. It was big enough. Okay, so we're going to now. I want you guys to look at this problem right here. Number 3. Number 3. So, a certain rectangle has an area of 252 square meters. The rectangle is 7 meters wide. How long is it? How long is it? So, first, the question is to make a sketch that shows what I know about the situation. So who can help me out? What should I do with this? Tita? Division, okay, so you're looking at the equation. What would I do with the equation? What would I divide by what? 2 divided by 7, okay. Very good, so put that in the equation spot. And then, what should I do with the rest of it? Okay, go ahead, Evelyn.
What question are we on for problem number 3?
We're gonna do A. So she answered our equation, right? So that is gonna be 252 divided by
For
7.
this sketch, do a rectangle,
Rectangle.
and inside the rectangle, write the number 252, and then on the, and then on the side, we put, 7.
7. Alright, perfect. Okay. So now, what I want you guys to do is tell me by using an array or a ratio table to solve this problem. Solve this problem. What do you do? I'll give you guys a little moment here to think about it. You got it already? You're gonna do the ratio table? Yeah, I'm trying to do the ratio table. So guys, work together and use either an array or a ratio table to solve this problem.
No, division is division is, I already figured it out. Division is 252. But it's gonna be
But that's okay, don't let that fool you. It's big, but it does have a little bit of friendly numbers, right? What can we do to break it up to make it more friendly? So how would we do that with an array or a ratio table?
You aren't supposed to stop. No, you are supposed to. Then how do you get to 200? I'm at 560. 560. What? You have to get to 200. Yeah, let's go to 252. 25 times 7. Oh my god. No, I am gonna launch you off this hill.
I'm at 280 right now.
Jeez, dog. Yeah,
I've been doing it.
trash. Dude, we're supposed to work together.
They're trying to figure out 252 divided by 7.
I'm not going to.
252 divided by 7. You get it.
Trying to copy down my answer. That's easy as
252 divided by 7.
25. 24.
Like 30 something?
Just tell us what it's in. Is it 10s?
Get closer.
Probably
15s.
not 15.
Yeah, 15 and a half.
So can you do bigger jumps to get that? A little quicker?
It really is.
I did the over strategy.
Oh, I should really show you. Flash it.
Did you maybe, yes, you have your hand in here. Could you maybe double that?
Then you put up 20.
The answer is very easy. Oh. Wait, Joey, don't. What is it?
Bring the chopstick. Bring the chopstick.
So Marley, Marley will be able to see
So, are you saying that 5 grades?
Figure it out, Sharon.
So, show me how to stick it real quick.
This is from
Yeah, we got it.
You want to share yours?
Oh, yeah, Marvin has it. Let me. I
Go
was.
another minute here and think about
Why are you talking about me? I'm going to get seven. My pen is here. What the heck? Tell me why. Oh, this is great.
Alright, but LIS? Alright, so why do I come in and share what you did?
They spell bite. They spell bite.
What I did is,
So dumb.
7 times 2, I could, well, what I did here was I kept doubling until I got to 36, so I did
I didn't know it was 36.
7 times 2, which is 14. 14 times 2 equals 28. 28 times 2 equals 56. 56 times 2 equals 112. 112
No,
times 2
that's not
is
5.
24. But I couldn't double it by 2 because that would be 25.
But the one, it's at the corner.
So what I did is I used 28 plus 224 equals 252. So I added 4 to 32 to make it
36. Yeah, it's a 36.
Agreed.
Agreed. Want to share yours?
I did the over strategy.
Oh, strategy, okay. Okay, goodbye, thank you.
First I did 1 to 7. I jumped right to 10. I know it's gonna be a lot. And then I noticed 40 is too much. So I went down 5, 35. But then I noticed I went too low. So I went 1 low. So then I did exactly what I did.
Alright. And you see how we even the bigger jumps there? When we're using big numbers, we don't want to go by like 2s, right? So you notice how he went right to 10 and then kept doubling it from there. Make his number nice and easy to work with. Yeah, oh, go ahead, Evelyn. I'll show you. This is usually a different one.
I started with 10, and that was 70, which was 20, and then
1 second. LIS.
PN.
Alright, so let's put our attention on Evelyn for a minute while she's showing what she's doing so you guys hear.
So I did 10, which was 70, 20, which was 140, 30, which was 110. And then I knew I needed 25 more, and then I knew times 7 was 35. So then I did, well, I needed like a few more. So then I did, and then I realized that that wasn't enough, so I did a 1 and 7, which was, so then I did 30 plus 5, which was 47.
Okay, very nice. You guys catch what she did there? So she doubled at first, got to 20. She knew if she doubled it again, she was going to get too much. So instead, she added her 20 and 10 together. So her 140 and her 70. She got 30 and her 10. And she knew she needed more, but not a whole nother 10 more. So she took that 10 and divided it in half to get her 5 back, which is going to be 35. And it was still just a little bit too little, so she added one more group of 7, and that got her an answer of 252. So then what she did was added these numbers together, so that's how she broke it apart. You guys see that? So she added those together to get her answer of 36. Alright, perfect. Thank you guys. Okay, so now what we want to do here is, if you could turn to, get out your math books please, and we're gonna turn to page 224. Alright, so we're going to just take a quick look at page number 224. Okay, because we're going to do this page during breakfast tomorrow. Okay, so on page 224. So does your guys' match? Yeah, yours is right. Oh, you guys are supposed to be. You're on 224? No, you're on 44. Okay. So we take a look at this. This is area challenges. So what we're gonna do for breakfast tomorrow is do this workbook. But I want you guys to at least do number 1, 2, and 3.
Okay.
So basically, if we get the 1 out of the 2 pages done in the morning, that will be good. But if we take a look at this, it's telling us, it's basically the same kind of problem that we were just doing. So the first problem says that a certain rectangle has an area of 693 square meters. This rectangle is 7 meters wide. How long is it? And it breaks it down the same way that this problem did, right? So it wants us to make a sketch where we know about the situation. So that's where we drew the square, or the rectangle, and we put our 7 and our 252. So you're gonna do something very similar to that. And then it wants us to write an equation to the problem. So that's where we got the 252 divided by 7. That's our equation for the example we did earlier. And then it wants you to use an array or ratio table. So it's very specific that you need to use one of those two methods to figure out your answer. Okay. That makes sense to everybody? Yeah, anyone have any questions? Too long? For breakfast, yeah, you can work with partners tomorrow during breakfast. Okay, any other questions? Huh? You did the first one already? Okay, very good. That's okay. You have another. You have more chance. Evelyn?
Are we gonna work with the partner right
No, because it's all about lunch or recess time. I wanted you guys to see what we were going to do, to have a good understanding tomorrow. When you come in, we're going to work on this page, okay? Hey, guys, you go ahead and get ready for recess.